Hi, Kevin. How your Institute for Internet Security is doing?
Oh yeah, funnily enough, after speaking last time, I remember you were like talking and suggesting like at one point we might also do some more stuff in Java and so on. And actually, we finally do some more engineering programming stuff, and we do it in Java now, or it's in the beginning, but it's proposed to be in Java, and is supposed to be kind of like a benchmarking suite or benchmarking framework for different blockchain technologies.
Perfect.
Yeah, so I'm also very happy to bring the whole topic into the Java game. It's also more comfortable for me like this. So yeah, I'm looking forward to this.
Yeah, perfect. But so what I also did, I prepared a little bit for this time for the show. And first, Iron Cobra is amazing. So I found the band
Thank you.
on Apple Music actually even, and on YouTube, and I saw you playing guitar. And I have to say you are amazing. So for me, it is not that much difference between you and Kirk Hammett from Metallica, I would say. But I cannot play.
Thank you very much.
But I cannot play a lot of guitar. But I think the audience will also say that. So probably you are not you have no time to practice a lot. But what I heard is really amazing. So it's just like for me, it's really no difference. But yeah.
Oh yeah, thank you a lot. It's very nice to hear. And yeah, you're right. So I'm not practicing that much anymore. But when I was a student, I was really practicing a lot. And I used to have a job in a hospital where I was just sitting at the entrance, like this job where you sit at the entrance and send the people to the rooms. And when I was having night shifts, I would always take my guitar with me, and no one was coming at night, of course, so I could play guitar all night.
Okay. This might be interesting, practicing death metal in a hospital. This could be very inspiring for the patients.
Yeah, but it was like playing the electric guitar, but without amplifier. So like really stupid exercises all night, kind of this.
Yeah. What I also did, I took a look at Mugen Psyche.
Right.
Yeah, and the cars look boring but fast. So it looked like it is like pro play toys, I would say. This is like lots of carbon and aluminum, and they look fast, but like this is more like a weapon than a toy. The Tamiya are more colorful, with lots of stickers, and the Mugen Psyche just look fast.
Yeah, exactly. So it's not really a toy; it's like a sports competition model. Yes.
Yeah. Then what I also did, I researched the Uli John Roth, and I found him on YouTube as well. And the guy looks like like a guru. This is like the James Gosling for guitars for me. This is what yeah. And he even developed his own guitar because he wanted to play more classic stuff. What I understood. And he's really amazing. So I never heard about him. And what I also found, that the Uli John Roth played with on the G3s. G3 is now like the how to call it, a concert where a fun concert where the how it's called, the guitar heroes. I forgot the names. Like the Van Halen and people like this play together, just fun stuff like Voodoo Child and the G3.
Malmsteen there, and yes, sure. From I think Joey Satriani is like the original originator here.
Yeah, Joey Satriani and stuff like that. And the Uli John Roth also played with them. So for me it was a huge win the last podcast. So I learned a lot. So now I'm back in the game in metal.
Oh, excellent. Yeah, I've seen Uli John Roth a couple. So actually, I know many people call him Ross, but he's called Roth because he's from Germany.
Okay.
Uli John Roth. And I've saw him a couple of times live, and it's always really amazing. Like you get this feeling from being live at a 60s, 70s rock concert, because he plays this extensive Jimi Hendrix kind of style, like very loud and very expressive. Okay. And I also played one concert, didn't play together with him, but at the same festival, both our bands played. So I could make a cool picture where we both had a guitar in hand. So like as musician colleagues, I could met him. I was very proud of the moment.
But there was I think there was one time, David Lee Roth. There was also someone, right? He was also a guitarist. Is it true?
No, he's a singer from Van Halen, or?
I have no idea, because I remember right now Lee Roth. This is why I confused both. Okay, it could be a singer. Okay, the only thing which I couldn't find is the reference to the red car. So you said, what was the name of the red car from your avatar from Twitter?
I thought it was a Dutch Defender.
There is no Defender. So I know I spent probably 20 minutes researching the Defender. I think it is Charger.
A Challenger then.
What
Charger?
Charger or Challenger? And you had
it's the Challenger. It's Challenger.
Oh, yes, very good. So very good. So I was really I was what I can do. I cannot do more research, but there is no Defender. But Defender would be a great name. But there's a Charger, I think, and Challenger could be as well. But there is no Defender. And you had the opportunity to take a ride with the car, or?
I when I was in Las Vegas or in Nevada, I rented a car, and like in the US, often when you come, they say like, "Oh, here, free upgrade, just take this car." And then he just gave me this car, and then I was super happy. So this was my rent car when I was in Nevada.
So you actually ordered the Toyota Prius and you got the Charger, right?
Kind of like this, yeah.
Cool. And it's nice. It's nice to drive, or how is it? I mean, I never drove such a car.
To be honest, so I'm very used to like the German cars, like VW or Audi or whatever.
Yeah.
And compared to those, I found kind of trashy in many ways.
Okay.
Like,
but the sound was nice, but at least.
Sound is good, yes, but like also it has automatic gear shifting, which is of course okay in theory, but compared to the more modern gear shifting in like the German cars, the DSG system, it feels so slow. It's like has less attack, and also all the driving handling. You feel it's a really heavy car. It has a lot of horsepower, but since it's also such a heavy car, it's not like handling nicely, I think. But it's cool for driving on the highway in the US.
Yeah, but this is better suited, for Twitter avatars than VW Bittel or something like this, right?
Yeah, I agree with that.
Okay, cool. Now let's start. So the last time we started, to talk about testing. What I would like to do is I would like to explain what I am doing, and then we can discuss, what you could suggest, or just discuss my approach. So
yeah, very good.
So what I'm working mostly with the backend. So I do also front end stuff, but this is, I would say, out of scope for this talk. And at the backend, I'm usually working with application servers or runtimes. Like right now, I would say still most of my projects are Payara Whitefly and Open Liberty catching up. And new projects, there are some projects I'm using Quarkus. But all the projects, they mainly, microprofile and Jakarta EE. This is what I'm doing, or at least what my clients demand from me, or in the cloud native spaces. This is what's going on. And we have bare metal. There's almost no bare metal deployment. So mostly we have in our Vue projects Docker. In the vast majority, something like Kubernetes based, and this is OpenShift almost everywhere. And in Vue cases, we have plain Kubernetes. So this is my environment I have to deal with. And in the Kubernetes or OpenShift, we have 3 stages, like mostly dev, int, and prod. This is common. In some smaller project, we have just 2, like int or int and prod, and the dev is locally on our machines. So and what's for me the most important thing is that all the developers, so this is usually small teams, I would say pizza teams, 2 to 5 developers, that we all commit as much as possible and run as much as possible integration tests on the central OpenShift. And we use usually the built-in Jenkins, which ships with OpenShift, so everything is integrated. So you can imagine every commit and push, the Jenkins will, so it goes, for instance, to GitHub. There is a push hook. The Jenkins will wake up, check out everything, and then it will perform first build, then unit tests, then will compile first the thing, then perform unit tests, then we'll perform integration tests, then compile the system tests, then start the environment, deploy, check the readiness and liveness probes, and then perform system tests, stress tests, and if we like, if this is release build, it would create a tag and push it to the Docker registry, which ships with OpenShift. So this is the main cycle, roughly. And locally, I basically don't care what we are using, because the most important part is the CI. So what happens locally, we use server or runtime, which is similar, or the best would be identical to the runtime we are using in the integration and dev tests. And I don't use Docker at all. So what I'm using is, let's say IDE, NetBeans, sometimes IntelliJ, in 99% still NetBeans with Whitefly or Payara integration, or now with OpenLiberty, I use a tool I wrote called WAD, which is very simple: watch and deploy. It is could be seek and destroy, but was actually watch and deploy. And what it does, it just watches the changes in sources, then does Maven clean install and just deploys that. This is a simplistic tool. So it means locally on every save, the project is deployed, so I can just very well debug whatever I like. And locally, I also perform the same thing. So I'm able to execute unit tests, integration tests, system tests, with the difference that the system test talks to the locally deployed server. And the only thing where I think test containers, where I use test containers, was if to start the database, the Postgres, to launch and stop the database. But what I usually did was port forwarding. So we install Postgres in the dev environment, as many developers we had on the OpenShift. So with OC port forward, I could actually work locally with localhost, let's say 5432, and it just forwarded everything to OpenShift. And the downside with that, of course, is I had to clean the database manually. What meant I just did OC rollout, so the database was rolled out on OpenShift, and then it was started with not empty, but with the test data. So, and with the test containers, it's great because I could automate the cleaning. So I could locally or on OpenShift start the Postgres, and after the tests, I got the initial state from the database. So this is what am I doing? And the last time I got the impression that you try to do something different. So let's talk about that. So why you are doing something different? So this would interest me.
Yeah. So of course, with these solutions, there's always a spectrum. So there are certain advantages of the way you do it, and there, I think, are other advantages of the way we as test containers think about certain things. Mm-hmm. And what I use as my main story when presenting test containers to a new audience is telling that I want I want test containers also to allow for a seamless onboarding experience, in the sense that a new team member can just check out a project and directly run the Maven build or run the Gradle build or whatever, and everything works without him having to configure to install anything locally. So that is kind of a goal I try to communicate for people who want to start using test containers.
Okay, this means your Maven POM contains all the logic, because in my Maven POMs, there are roughly, I would say, 30 lines of code, or this is we only have a API dependency to microprofile and another one to Jakarta EE8, but we don't have any declaration of plugins and so forth. So locally, I would just use a script, and globally, basically a script is like 10-liner or 5-liner, and on the Jenkins, there's the Jenkins file. This is the automation process. So your idea is to put everything to the POM, not everything, to automate the process in POM?
Actually not. No, okay. No. Not as part of the POM, but as part of, for example, my unit test.
Okay.
Yes. So let's first assume black box integration tests, which is probably what you to refer with system tests, I think. Or
yes, exactly. Exactly.
Mm-hmm. Okay. Mm-hmm. So those are a bit more simple to do also with test containers in the context of JEE, because there you can, of course, just start your application server, including your application as a Docker container and instrument it from the outside.
Exactly.
So and this is what test containers can like also do, not only start your dependencies for your integration test, it can also like manage your whole system basically. So you can use it to describe all the components that interact with each other and then do a black box test of this. Yeah. So and then someone can just check out the project and directly do it without having to know anything. And also still the only entry point is the Maven failsafe plugin or wherever you want to put this.
Okay, but someone will still have to have IDE, so environment. So I will have to set up my server anyway somewhere, right? So I will have...
yeah, so depends on how you work. So
yes.
As I said, there are certain drawbacks to this. And for JEE, I found some things more tricky than, for example, with Spring Boot.
But we could do Quarkus. Quarkus is from, it's just single jar. So you can just start wherever you like. So it would be like Java EE. So for me, I always have to Spring Boot, Java EE, and Quarkus, almost no difference. So what's the only difference is, there's no difference. What I wanted to ask you, what about liveness and readiness probes? Because usually I would implement them for Kubernetes. And in your particular case, these I will configure the test containers to check the readiness probe, right?
Exactly. So, this would be the waiting strategy, what we call waiting strategy. And what you can do, and once you have a little bit more complex system, you can just easily write your own class, extend generic container class, to write your own container test containers abstraction for your application that can already include those waiting strategy, or you can even basically implement a class that abstracts away your whole system. So inside this class, you describe all your dependencies and how they attach with each other with multiple networks or whatever. And then you can, in your test, have a high-level API to start your whole system.
Now I found probably a killer feature for test containers. Because what I sometimes hear, that the developers say, hey, the OpenShift is slow, and we would like to start everything locally. So actually, what we could do is to just take, use test containers to run actually the OpenShift checked in Docker container, the OpenShift version of the environment locally. I mean the application server or the runtime with the app locally. So you will, because you could run, for instance, a Jenkins test or Jenkins build on OpenShift. So the output of this pipeline is a Docker container. And with test containers, I could automate the thing. If you like, I could start it locally, completely locally. So I will have identical environment to OpenShift, right?
Yes, basically. So as long as OpenShift just creates environments out of Docker containers,
yes,
it's possible.
It does.
Yes,
it does.
Yes.
So and the problem is why I don't like to use Docker locally is because Docker locally you can do whatever you like, and OpenShift Docker is more restrictive. So you're not allowed, to write everywhere. You are not allowed to be the root. So what sometimes happens is, developers using Docker locally, and they never manage to ship to OpenShift because it's more restrictive. So for me, it's crucial that we integrate as much as possible on OpenShift. But with test containers, it would be a great way to automate how to pull the OpenShift environment locally. What also is the case on OpenShift, the Jenkins itself runs as a Docker, actually 2 Docker containers. One is master and the slave, because the slave is the Maven slave. And actually with test containers, this would be great. We could actually try to run the entire Jenkins pipeline locally, because then if something breaks, developer could say, okay, now I run my entire automation test without any implementation, just, I run my Jenkins slave locally. You know what I mean?
Yes, definitely. So I don't know if we talked about this last time, but test containers is in its core actually not only something you can use for testing, it's basically a more convenient object-oriented API for Docker.
Exactly.
So,
this is
therefore it's very flexible. Yes.
Yeah, and I forced you almost, to separate the Docker API from the system test, and you told me that this is in planning, so the next release is going to be more separatable.
Yeah, not directly the next release, the next major release.
Oh, the next major release, of course.
Yes.
Then we need this the safe harbor statement where so this is
exactly,
no one has,
exactly.
Yeah. And but this is actually this would be great because you could do whatever you like locally. You will push as often as possible to Kubernetes or OpenShift. It will build, and if something going strange, you can still locally say, now I would like to run the pipeline locally, and it will run. Because what I don't like is that we get locally a different environment than the integration environment.
Exactly. That's also, I think, I struggle with those kind of things when you are starting to rely more on the services or the features of your CI environments or whatever. Then it's not that easy to reproduce those kind of specific environments anymore locally, and then you have some hard times sometimes with the debugging. Yeah. So right. If you do those things locally, you can, in worst case, easily debug into your processes or into your containers, attach a remote debugger still more easily than into the OpenShift environment also.
But let's assume we have just Quarkus. This is one jar with some other jars, but basically it is a thin jar. And what you will do? I mean, forget now our conversation. So what you will propagate on conferences or in your project. So if you have just one jar which is executable, what you will do then? What will be your default approach? With test containers.
So this depends now if I need to do a white box test or a black box test. And with white box test, I would mean in-process test.
Yeah, let's go through the whole pipeline. So we need unit test, integration test. Integration test would be like testing Hibernate. So we have like unit test which tests one Java class. Then we have a test which tests Hibernate, which goes to Postgres. And then we have black box test, which invokes a service over the wire. So let's say we have the three parts. Yeah. So what you will do?
So, unit test, nothing to do with test containers there. Okay. Just the normal unit test as always. Then integration test. Now I'm not 100% sure how Quarkus exactly works because I have just seen it on conferences. But what you need to do when you want to connect your integration test with test containers basically is have some kind of way in the life cycle of your test. First, start the containers and then inject the dynamically mapped port into your application context, configuration, whatever, before your application context starts. So with Spring Boot, you can, for example, do this by setting system properties or environment variables or something like this. But you have to have some hack in your test environment or whatever. Make sure your JUnit code executes the test containers code to start the containers before it starts the application context.
Yeah. And this is the main difference to Spring Boot. In Java EE or in Quarkus, what we would do is this test is called integration test. So it would end not with test rather than with IT. And what we usually do is the code looks like entity manager factory, create entity manager factory, and we get the factory, and then we can set properties, IP addresses, whatever you like. And then I get the entity manager, which basically is Hibernate. So we don't even have to start the application server, or we actually never start the application server for that. We only start Hibernate or Eclipse Link because it's faster, easier, and we don't need the application server to test, the persistence. So we have two lines of...
You are instantiating the object itself from your test code.
Yes.
Okay. Then it's super easy because then just before you instantiate your factory. You just need to start the, for example, Postgres container beforehand, and then you can directly use its getter to get the dynamic JDBC URL, because you can't hard code the URL anymore when you use test containers, because with every start it will map to a possibly new port, because it will always map to a free port, and if you would parallelize or whatever, you have to programmatically access the URL. That's the idea. And then you have to inject it into your system under test.
And this is what I do, and this worked perfectly. This is exactly what we do for integration tests. And the last time I had, as we spoke about, and on our podcast, I had the feeling that you're doing something different. And I said, okay, probably I could improve that. But this is exactly what I'm doing, and it works great. And I can even choose whether I'm using, the local OpenShift in Docker container or the remote from OpenShift. It worked in both ways directly.
Yeah, so like nothing against this. Just with Spring Boot, you have some special things that are a bit different, because you have to integrate against the Spring Boot test framework, which handles this auto configuration thing. And in this case,
and why? Why they are doing this? You know this? Because I always ask developers, why do you starting Spring Boot if you just would like to test the persistence? But they never answer that.
Because you're potentially doing a little bit bigger tests than just the outside persistence or whatever. So just you're in your CDI context. That's the idea.
Okay,
and but you can also inject the beans.
Okay, we don't do this. So what happens in my project is, let's say we have a guitar JPA entity, and we would like to test all the queries. And then I would just test the queries, and the CDI tests, we actually never tested in the integration tests to force more system tests or black box tests. Because in most projects, if we have problems with environments, timeouts, bottlenecks, performance problems, and CDI mostly works. And the CDI in Java EE is that simple. So really, we don't have qualifiers, we have no alternatives, we have no stereotypes, we have just add inject, so it cannot actually fail. We don't even have interfaces very often, so most we just inject direct classes, and this is basically it. So the I would say the recent 5 to even more 7 years are extremely pragmatic. So we have just few classes which are injected in the persistence, and this was caused by microservices probably movement, because we have just we expose REST and JSON to the outside world. Then we have one resource, which with a view of annotations, then facade. And in this facade, we already directly inject the entity manager. And this basically it for CRUD, create, read, update, delete. And if there is more logic, then we have a class in between, which maintains the logic. But we have nothing else. So this is 80% of projects. So there is nothing else to mock out. So this is why we use directly Eclipse Link. And this is that simple. Okay, so I got the idea. So, and the same would be probably if I'm testing, let's say, bin validation, I do the same. I just instantiate the bin validation and test my validators. And if I have JSON serialization, then I just instantiate this serializer and test the serializer, but I never have to run the whole runtime. So this is the idea, because the applications are very thin.
Okay. In this case, it's easier. It's really easier to integrate test containers then, because you have the control. You're not in the framework context while testing. Exactly. So you don't have the inversion of control problematic there to hit the right point in the life cycle to inject the configuration of the container, because then you can do it by yourself.
Yeah.
It makes it a little bit more easy.
But from my perspective, this is the right approach, right? Because why I should start the application server, let's say, or Quarkus, to test the persistence. This is why I never use, Archelion?
Yes.
Yeah, I never use that. So because
I found it also a little bit painful, to be honest.
Yeah, not painful. It works, but the problem is there is no use case for me for Archelion, because the business projects are easier. And in the only case where I use Archelion or CDI unit or stuff like that is where we have a more complex CDI, because then you can vary with Archelion or CDI unit or Delta Spike, for instance, the contents of deployables. So I can say, look, I'm injecting the interface without implementation, injecting the interface with 2 implementation, or injecting the interface with 1 implementation. And we can test all the variations. So this was actually the killer use case, or it still is, from Archelion, shrink wrap, and CDI unit. But in my more or less boring projects, so we don't even have qualifiers, so we just inject always in our class. So it actually, in the recent projects, it never failed, because I mean, well, okay, if you do the constructor private, so this what can happen, but you will find it immediately in system tests as well.
So there is one thing, one kind of class. I think that's a class of tests that is good, or a different kind of class where it makes sense to have this kind of Aquilion test or Spring Boot test. And this is where you actually want to do kind of a system test, but you're a little bit too lazy to go through the public interface, or it's more convenient to do it in process, because it gives you maybe easier capability of setting up like the test data, or like just stimulating your system. So this is the thing, like it's a possibly easier API than going through the REST endpoint. And that's what I found. Many people use the Spring Boot tests for this, so they kind of want system tests, but they just start already in process.
You're absolutely right. And this can happen where, let's say, you have coarse-grained REST interface, and you have crazy complex algorithm, and you would like, to access the algorithm with the database, with injected database, and this is hard to have to cover all the test path through the REST interface. So this could be the case, and we had it once in a project where we couldn't easily, go through the REST interface and provide enough variations to test, all the corner cases in the algorithms. But what we did then is, this was interesting, we basically implemented, or we had an alternative deployment where the business logic was injected as is to a prepared test bed container, which exposed via REST everything. This is very simple with CDI, so you can do kind of similar to reflection. So we could access whatever we liked, and then on the client side, we read Excel sheets and had something like fitness tests without fitness, because we got the Excel from the business department, but we were able to cover almost everything easily. But for this scenarios, I can see the point. But this is not very common in my world. It is even dangerous, because what developers always forget to do is the following. They run, with default set of threads, no timeouts, no liveness probes, no readiness probes. They go with the defaults. So it means it will immediately run in their environment, and it will hardly run on the integration environment, because the container will start, the cache is not pre-populated, or the configuration is not fetched. Then they try to system test, and it is too early. So there are the common problems where you can spend a lot of time if you don't have frequent integration. So this is my problem. I don't know whether it's a good idea to have too convenient local environment if the most problems happen in the integration environment.
Okay, but if you would like locally instantiate your local test environment also with test containers, it would also mean you have a fresh instance of an application server.
Yes.
So you would have those implications there and see it early.
Yes.
Potentially.
For instance, on OpenShift or Kubernetes, the application server is never the problem. So the problem is, SSL certificates have to be, provided by the system. And sometimes they come too late, or they don't work. Sometimes you have the problem that the load balancer behaves strangely because the system is overloaded. Sometimes, the network is slow, so pulling the resources takes too long, and nothing is built. So, but you have to, to use the central environment, and So what I just propagate, use it as often as possible, and the application servers itself, it is no more the problem, I would say, because this is just, I would say, one process which is orchestrated by Kubernetes, which is larger problem than the process, I would say.
Yeah, of course. If you have also like a more complex environment that you are using, like for example with Kubernetes, then you want to also already test the integration into this environment, which you can't do that easily with test containers. So right now you can't do Kubernetes stuff with test containers.
Yeah, so no basic stuff like if you have Kubernetes, you have to have ingress controller. OpenShift is called route. So sometimes the DNS name is auto-generated, and if you use the wrong name, but you have to configure the name if you have two microservices, then it won't work anymore. So you could use the IP address, but the IP address depends on environment. So you will have to test the Kubernetes specific, let's say, cloud native configuration as well, which is never a problem locally because we can use localhost or we can get the IP address from test containers. So this is what I'm struggling a bit. So, but I think the killer use case for me with test containers would be really try, to run automatically the Jenkins from the global Docker container locally. So this could be an interesting part, and as well automate the process to pull the already built Docker container from OpenShift and run it locally in test containers in automated fashion. Because if you don't do this with test containers, it's a little bit painful. So what I will have to do locally, Docker pull and use the right tag, and then Docker run and wait until it starts. And with the built-in capabilities, how you call it? Not readiness probe. I forgot the name.
Wait strategy.
Wait strategy. With the right wait strategy, you will save a lot of time.
Yes. And you can also, I think we have a setter on the container instance to say with pull true or something like this, that it always pulls. Like if you would have your latest tag you want to use or whatever. Of course, it would be better to specify a unique tag version or a SHA of a tag. But in case you always want to test against the latest tag, you have, of course, do the pulling, but then you can also force test containers to do this.
And what I sometimes also do, so how I'm dealing with that, so I'm starting with scripts. Scripts means Maven clean install, then Maven tests, Maven fail-safe integration tests, then Docker run, Docker deploy. Not Docker deploy. We deploy this with what deploying to the application server. Then I switch to the other module, and then I perform black box tests. And actually, from all these scripts, could be also an idea to try, to have kind of a pipeline which runs in test containers, right? So you could try to automate the whole thing and have, how to call it? So a small CI pipeline within a test container. You know what I mean?
I know what you mean, but I never did this. So
no,
I
just
would need to think this through.
just brainstorming, because
to
have something automatable and could be also interesting. So you don't have to use Jenkins. You could just say, okay, first step, next step, next step. So we will have test container orchestrator of other test containers, something like this.
So yes, in theory, in the end, test containers is just more Java, more object-oriented Docker API.
Yes.
So everything you can, nearly everything you can do with test containers. Just one thing you currently have to be aware of is the fact that test containers is built for itself to remove all the containers after the JVM exits. So that's just something to keep in mind, a current limitation. But actually there is one new feature we have now in alpha, and I'm also not sure if I mentioned it last time, but this is specifically for local development environment and the reusable container feature. And in this case, you are specifying certain containers to be reusable, as like on the object instance when you instantiate the object, and also you set your local environment to use this feature. And in this case, the containers will not be killed after JVM exit. They will have a certain grace period. They will be kept alive like half an hour or anything. And then when you run the test again, test containers will check. It creates kind of a cache key for the container creation. And then it will check, okay, do we already have a container still running with this cache key? And then it can reuse this. And that's very good for certain kind of test-driven development like cycles, integration test-driven development, if you would like to call it like this, where you want to constantly test your queries or whatever, and without having to restart your containers.
Yeah, it's just brainstorming. What we could also do, use just a dedicated unit tests with the sequence of test container invocations would also work.
Right? Yes, so what you can also do, and I've seen people do it, it was in the context of Spring Boot, but it doesn't matter, it would work anywhere. Use a class with test containers to start your local interactive test environment. So basically just start your application container and all the other dependencies and then leave it running. And then you have a local environment for testing, and you don't need any other facilities like Docker Compose or any scripts to set things up.
Exactly. But Docker Compose starts multiple Dockers in sequence usually, right?
Not directly in sequence, in parallel, but
in parallel, yeah. So, but this is the dependency between containers, yeah. Exactly.
Yeah.
And what you are saying is you can use test containers to launch a single container with all the things, or multiple containers?
No, multiple containers. So what we would do in a Spring Boot project, for example, we would have a test class, for example. It's just like a main, but in our test sources. And this would maybe start the Spring application, not as a container, but just like manually, and also start all those dependencies like databases, Kafka, whatever, and then keep the application running. Like basically like you would normally run your application, but you can be sure that all the dependencies are there. And that's also great for having like a demoable version or whatever. Everyone can directly start it without having to install anything.
Yeah. This would be like demo environment. Yeah, this could also work. Yes. This is also a good idea. But
demo environment or interactive test environment.
Yeah, but they cannot easily replace then Spring Boot. They will have to restart the container, I think, right?
Exactly. Yes. But so you can't have this like hot reloading feature also in this
But
case.
The cool story is this would perfectly work with Jakarta EE application servers and WAD, this WAD tool I built, because the application server will run and I will launch WAD locally. It will watch my source folder, create the wars, and redeploy them in the running system. Also a great idea. This would perfectly work with Jakarta. It would not work as well with Quarkus because we have the problem that the jar is actually started. But for all my other projects, this is perfectly usable. Cool. Hey, what's your opinion about Quarkus? So you see Quarkus in the wild. You heard something about Quarkus?
So far, I've just seen the demos at the conferences. So I don't have any hands-on experience.
Okay.
So yeah. So I also I was initially like when the whole Micronaut thing started, I was I was not directly involved in this, but since I'm very much in the Groovy community, I was like close to the whole Micronaut thing. So I know a little bit more about Micronaut, but then Quarkus, I didn't really look into it. I just from my outsider's point of view, it just looked like something similar to Micronaut.
Yes. Absolutely, and also similar to Helidon. But the interesting part is we can use the old microprofile in Jakarta model one-to-one. This is a difference. So in my project, it really takes off because people can just one-to-one migrate their old projects to Quarkus, which is interesting because wherever I am in the projects, it'll say, hey, if they complain, we need more memory or whatever, it's like, have you tried Quarkus? Yeah, we're already evaluating it. So it's like Quarkus is everywhere. So which is interesting. So this was the question, how you perceive this.
So for me, what I really like right now about the Java web framework space is that we are having a little bit bigger diversity. So that's just something I found I find very healthy, and we have different options for doing microservices or whatever, and that's just good. Like it just shows activity in the community.
Very good. So the last question I wanted to ask you, because I'm a freelancer consultant, and the problem is it is a really bad idea to use your own name. So I try to find a standard naming. And what I usually do, you have no idea how to name things. I look up Wikipedia. So my naming, unit, integration test, system test, stress test, or torture tests comes from Wikipedia. But there are some people think that integration tests, they launch their runtime, but for me it's forbidden. It's like, hey, look, integration test just means more than one method, and we will probably also use the file system or a database, but we don't have to start the whole runtime, because the next test is system test, which is a black box test. So which names are you actually using? So what kind of test, what is the proper naming of the whole test? Because I'm a little bit confused now.
So yes, I use similar names like you, but it seems I have a different context boundary in them. So, okay, unit test is for me tests of classes and objects that are owned by me, that are my code, but also if I would have two objects of two different classes interacting with each other in process, all in memory, I would personally still consider this a unit test.
Okay.
Then integration test. Yeah.
Me as well. If you know, if you have two classes and we don't need to mock them out, so because this is what we need. What I will do in Java EE, I want still instantiate the CDI container. What I will do in tests, I will do new class dot field equals new other class, and it works perfectly.
Okay. Yes. So I would normally like write my classes the way that I can do constructor dependency injection. Then I just can do it by hand, like just instantiate the object, put it into the constructor, and then I don't need a CDI or whatever.
Exactly. I also don't need a CDI because I don't have private fields. All fields are package private, and this is perfect. And constructor causes more code, so I don't like constructor injection.
Yeah. So I'm in the field where I use final fields and then have a constructor.
Okay. So we would already have some fights in real project if we will meet. So I think okay. Perfect. Yeah. So okay, this is the unit test. Okay, next one.
Okay. So then integration test. In general, I say when my classes need to interact with external dependencies that are mostly outside of my control, and some things are obvious, that are things like file system, network stuff, databases, and so on and so on. Also, if I would need to interact with my runtime environment, like a bigger runtime environment, like a context or whatever, application server context, and so on, and I do it all kind of white boxy in process, then that's for me an integration test.
Yeah, I'm with you, except in process, no. It is always, started outside the process, but identical. And what I like, I didn't thought about that, your definition that is this outside my control, like database and file system. I do it I did it without knowing why, but this is a nice definition. So I will just steal it from now. So really, because something which is not in my control is an integration test. This is actually a great definition. Okay, perfect.
Yeah. So there's one point in this definition where I struggle, in the sense that I'm not sure if I would call it integration test or unit test. And this would be if I test against libraries that are, of course, not in my control, but that I can use like completely in process in memory. Like maybe Guava or whatever. Like,
that is okay.
I don't know.
This
is this an integration test against it? Yeah, I would also call it unit test, but from this definition of control, it would be maybe an integration test. But yeah.
But I would say for microservice-like projects that run as a services or processes, this would be for me an unit test. If I would have a standalone Java desktop application, this would be probably more integration test, because the Google Guava or whatever is a big deal for me. On application server would be unit test.
Yeah. So yes, And then
wait a second. We could actually define that the integration test is whatever process is outside our control. So we have the main process, and if we need other processes, this could be an integration test, right?
Yes, definitely for other processes. Yes. But like if we consider having a framework that implies inversion of control on us, and we're testing against this inversion of control, then it's happening in process, but still we're an integration test against the inversion of control.
This is
framework.
What I have to think about to prohibit this, but but you are right. Yeah, because file system could be also kind of different process because it's an operating system. So I would define it as something outside, or outside our environment or something like this. Okay.
Yes. So when I often think about application architecture in terms of the hexagonal architecture pattern, and there it's kind of obvious. You have this outside layer, and everything which goes out of the outside layer has to be integration test.
But the funny part is in Jakarta EE, from the hexagonal architecture, we only get a pipe because we have in the front end, a REST interface, probably a database, and all others ports are open. It's really hard to find more. There was never a full hexagon in my project. We probably a triangle at most.
Yeah, it's mostly yes.
Pentagon would be well. In your case, you have to have a pentagonal architectures, right?
Yeah,
would be more compatible with Iron Cobra, I would say.
Yeah.
Cool. Okay. So what's the next level? So we have integration tests, and then.
I would also call it the next one. I would call system test, like you.
Cool.
And system test, I would say, is already a black box test, driving my applications through its public API, which could be a REST API or whatever.
Perfect.
And it also involves starting all direct dependencies, ideally as a real application.
Perfect.
Which with direct dependency, I mean, if I'm testing against another microservice, then ideally I can start this other microservices, but those dependencies behind this microservices, I of course have to somehow maybe mock away with wire mock or something, because else I have to have a too big system in some microservice architecture.
Mm-hmm.
Yeah.
Cool. And and stress tests are stress tests, because load tests are more formal, which I get from business department, and stress tests is what I do to destroy my system to see whether it's stable, right?
Yeah, I would call them load tests, but just because I did before, but stress test is also fine. It's maybe better. I don't know. I have no opinion on this.
Yeah.
But you would do this. Mm-hmm.
Larger companies, I have opinion, because what sometimes happen, we get stress tests, performance tests from the business departments, like more approval tests, what we have to do to be fast enough. So the applications have to just define behavior on the load. And this is boring because they have, wait states and stuff. So our system is never really under load with the performance tests. And the stress test is like brute force attacks. So denial of service attacks on our environment to see whether everything, fault tolerance is working, and, timeouts are working, stuff like that.
Yeah. So maybe this means also there are two different things. There are stress tests and performance tests.
Yes.
Like stress tests where you try to push it to the limit, and performance tests, which you could maybe also use as a kind of regression test to just see if changes you did now reduce your performance drastically. Mm-hmm. Yeah. And I assume those you would do against the same environment as a system test, or already
exactly
in a more productive one. Yeah.
And this is the reason why, for instance, I never use frameworks like REST Assured zum Beispiel, for instance. Because what do you use? We use the JAX-RS client. So this is like the the official remote client via API. Mm-hmm. And the cool story is we use JMH, Java Micro Benchmark. Yes. We misuse.
But I never used it. I just know it.
Yeah, this is actually cool, because this JMH it basically provides endless loops, or not endless, semi-endless loops with some metrics. And I just copy and paste my system tests and make in a few minutes a stress test, because I just invoking this in a loop, and then I getting more and more involved. So we are able to reuse the entire system test as stress test actually.
And does this JMH already record some kind of timings?
Yes. You get the output of you get throughput, single shot time, and you can control it by annotations.
Okay, this is excellent to know for my blockchain benchmark suite. Because I was already thinking like, maybe using JMeter, but JMeter is kind of weird to instrument.
You have to have JMH. And what you can do, it will create for you a jar which is executable. And but what you can also do, you can control everything from main method. And then you can even add exporters, which export, I think, is CSV or whatever. But if you do nothing, you will get, a system output, which is more or less scientific. So it looks scientific to me, like deviation from I don't know exactly.
So what I would want to do, I quickly explain and you say like, does it sound good or not? Is I would use test containers to start up the whole blockchain system, blockchain network I want to test. And once this is healthy, meaning weight strategy has been fulfilled, I would then just use JMH to put load on it. And I can do all this from Java.
Yeah, and you could actually run this JMH in another test container, right?
Oh, yes, I could probably, yes.
Because then you have two processes which you control. If you would run the JMH in your blockchain in one container, you don't know how much performance is consumed by JMH and how much performance by the blockchain. But if you have isolated containers, is I would say even more scientific, right?
Yes, maybe not as scientific as having different machines or different virtual machines.
The machines,
but it's a start. It's a start. Yeah. Mm-hmm. Yeah, so that's very good. But then JMH is just calling Java methods in the end.
Yeah, you have two annotations. One is called, I think, it's called not stress test, but similarly, like a test suite. And then you have, like before in unit tests, so you have setup, which you create a static context, which is passed to the real test. So you can have even something like varying arguments. So you can have, 10 tests with this URI and 10 tests with the other URI. So this is how it works. And it's similar to unit tests. So everything is configured with annotations. And you have a Maven plugin which creates the executable jar.
Mm-hmm. Okay, all right. But still, I would need to write some kind of Java web client to interact with the blockchain. Yeah, it's mostly exposed JSON RPC.
Yeah, and this is what I will use JAX-RS for that, for instance. Or in your case, JAX-RS client. So if you will look at my YouTube videos, there are lots of them. But in your case, you could even use the built-in JDK 11 HTTP client.
Yeah, sure. This is also a real nice one now.
Yeah, because there's even less dependencies, standard Java, so it was even better than Java EE. So just use the JDK 11 HTTP client and you are golden.
Very good. Yes, this was a very good talk for me now. I have some nice ideas about this.
This is for the listeners, you always have to wait until the end of the episode, right? Hey, cool. So what we should do in a Vue month, I don't think we managed to do this year. So next year, I would like to ask you how your testing is going with blockchain. So just have a chat about your blockchain endeavors then.
Yeah, that sounds good. And I hope and I would be optimistic that we can show something nice until then.
Yeah, January, February, something like that. February.
Yeah, or a bit later maybe.
March. Let's do something in spring.
Oh, yeah, very good.
Very good. Okay, then. Thank you a lot.
Yeah, thank you as well.
Bye.
I was happy that you invited me again.
Yeah, sure. It was a really nice episode, I think.
Very good.